Yes, Year 1 team, you are back and ready to get involved in our math skills lesson for today. We've got 3 different activities we're going to make our way through that we have done before, and I'm really excited to see how much progress you have made. We have got some key vocabulary on our board that we're going to use to help us explain that maths, because you know I really like you to explain what you know and not just do it. Okay? We've got this key vocabulary. We've got part, whole, tens, ones, more, fewer, equal. Great, so we're going to start with an activity that I think you quite liked the last time we did it. So this activity is called the house of. So in this house, there's only one number that can enter this house, and this number is 21. Well done if you managed to read that number. Yes, we've got 21. We've got 2 tens and we've got 1, 21. So we are going to look at all of our different ways we can represent numbers, and we're going to see which ones do represent 21 and they can go into the house. But if they do not represent 21, you know they can't enter our house of 21. Great. We're going to spot a couple together, then I'm going to leave you alone to solve the rest. So we're going to start off with our tens frame over here. As you can see, we've got a 10, another 10, and we've got a 1. So let's count those tens. 10, 20, 21. So can the tens frame enter the house of 21? You're right, yes it can. So we've got the house of 21, in we go. Great work. Now let's have a look at our 10 stick and cue our base 10. Right, let's count those 10 sticks. 10, 20, 1. 10, 21. 21. Can that enter the house of 21? Yes, it can. Good spot from you. Into the house of 21 you go. Now, I'm going to leave it up to you to realise whether the number sentence, the numicon, the money and the part whole model is allowed inside of the house of 21. Okay? You can figure that out for me. Off you go. Pause the screen. What did you find out? The money. We've got a 20 and we've got a 1. 21. Great work. What about the number sentence? 10 and 10. 10 and 10 is 20 and 1. 21. Great work. What about the part whole model? 19 and 2. 19, add the 2, 20, 21. Yes, it can go inside of the house of 21. But what about our numicon? What did you notice? 10, 20, 30. There are too many 10s in our numicon. We've got 31 and we only need 21. Right. We've got a different house now along the road. We have the house of 23. The house of 23. Now this one's all up to you. See whether the money, the numicon, the tens frame, the part whole model, the number sentence, or the base 10 is allowed inside the house of 23. Remember, only representations of 23, 2 tens, 3 ones are allowed inside the house of 23. Pause the video to give yourself some working out time. Right, so what did we think? Let's look at the money to start off with. We've got a 20 piece, a 2 pence piece, and we've got a 1 pence piece. So 20, 22, 23. So we've got 23 pence. So 23 pence is allowed in our house of 23. Good spot. What about our numicon? 10, 20, 30, 31, 32. 32. Can 32 go into our house of 23? No. No, it can't, can they? Our place value, our number is very, very important. I know these numbers look very similar, but 3 tens is a lot more than 2 tens, isn't it? That's one more 10. And we don't have the correct number of ones. Let's look at our tens frame. We've got a full 10, another full 10. So that's 10, 20, 21, 22, 23. Yes, we've got 23 in our tens frame, so that can go in our house of 23. Our part whole model, what have we got? 13. And 10 more than 13 gives us 23. It does. 10 more than 13 gives us 23. So that can go in our house of 23. So so far we've got one representation that can't. Should we see if there are any more that can't? So we've got here our 10 stick. 10, 20, 21, 22. 22. Can 22 enter our house of 23? No, it can't, can it? And then we've got 25, take away 1. 25, take away 1 is 24. So that equals 24. So can that enter the house of 23? No, it can't. So these numbers are very close, but they're not allowed in our house of 23. Great work. I hope you enjoyed that activity. We're ready to move on to our next one. So we are super good at working with our tens frame, and our tens frame is really helpful for us to see that there are different ways we can make that same whole. So we're going to be working with this whole for quite a while. What is that whole? Pause the screen and see if you can figure out which whole we're working with. Off you go. Right, so what whole did we have? Yes, we've got 17. I've kindly given it to you here. And we are going to figure out now what our red part is and what our yellow part is. And then once we have those, we're going to put them into an addition sentence, but also a subtraction sentence as well. Are we ready? So we've got 10 reds, 2, 3, 4, and another 5. 10 and 5, 10, 11, 12, 13, 14, 15. Yes, we have 15, part 15, and then our yellow part is 1, 2. That's a nice easy one, and a part of 2. So we know a part of 15 and a part of 2 makes a whole of 17. Part of 15 and a part of 2 makes a whole of 17. So how can I write that in addition sentence? 15 and 2 equals 17. 15 add 2 equals 17. Great work. But then, how can I write a subtraction? We must start with which number? The whole, don't we? We start with the whole, which is 17. And if I take 2 away, so if I take 2 away, I am left with 15. 17 take away 2 equals 15. Great work. We could also have 2 add 15 equals 17, and also 17 take away 15 equals 2. Great, it works both ways there. I'm going to leave this one up to you. So, complete the part whole model, recognising how many we have in our red part, how many we have in our yellow part. Once you have that completed, can you please write an addition sentence and also a subtraction sentence? Pause the video to give yourself some working out time. Great, what did we find out? Yes, we've got the red part is all in 1/10 frame. So that's fantastic for us because we can recognise it's 10. Then the yellow part is 5, 6, 7. 5, 6, 7. So we've got a part of 10 and a part of 7 makes the whole of 17. Let's say that together. A part of 10 and a part of 7 makes the whole of 17. Great work. So to add these two numbers together, these two parts together, we've got 10 add 7 equals 17. But if we were going to do a subtraction, we have to start with the whole, which is 17, and we might take off 10. And if we take off 10, we're going to equal 7. Can we see 17? Might take off the 10, and we're left with 7, aren't we? I might have 17, but then take off the 7, and I'm left with 10, aren't I? 10, add the 7 gives me 17. 17 means 7, add the 10 will give me 17. So these addition and subtraction number sentences can be manipulated to work in 2 different ways each. Another example for you to do now. As you can see, I've kindly left the whole at 17. You need to complete your part whole model, and you also need to give me an addition number sentence and a subtraction number sentence. If you could do both addition sentences, that would be fantastic, and both subtraction sentences, that would be even more fantastic. There's a little challenge for you. Off you go, year 1. Keep the video paused if you like more time. As you can see in the red, we've got 5, 6, 7, 8, 9, a part of 9. And in the yellow, I can see 5, 6, 7, 8. We've got a part of 9 and a part of 8. So I've got a part of 9, and we add the part of 8, we're going to equal 17. Because a part of 9 and a part of 8 makes the whole of 17. So we could have 9 add 8 equals 17. Some of you might have written 8 add 9 equals 17. It doesn't matter either way. Then when we've got a subtraction, we've got 17. And we can either take off the 8 and be left with 9, or we could take off the 9 and be left with 8. It works either way because we know those two parts make that whole. We have the whole, we take one of those parts away, we're left with the other part. Great work. So now, you've got the whole of 17. I haven't shown you it in the tens frame because I want you to do that yourself. I want you to think of a different way to make 17. One that we haven't done yet. So see if you can come up with a different way we can make 17. Write it in your addition sentence, write it in your subtraction sentence, but obviously you'll need your part whole model before doing that. You can use my sentence at the top to help you with that. Pause the screen, let's see if you can find a different one that we haven't done so far. Off you go. Right, so there are lots of different ways that you could have done. I'm going to show one that we haven't done so far, and that is, I'm going to complete my first 10. So I've got 10. But then I'm also going to keep going with my red part, because I think it's going to be bigger. And I'm actually going to do a part of that number there. So we've got a part of 10, 11, 12, 13, 14. So I'm going to have a part of 14. Do you think you can figure out what other part I need? I need a part of 1, 2, 3, don't I? 14, 15, 16, 17. So I needed a part of 3. So I now know a part of 14 and a part of 3 makes the whole of 17. So that means I also know that 14 add 3 equals 17. Or 3 add 14 equals 17. And I also know that the whole of 17, if I take off 14, I'm going to be left with 3. And if I take off the part of 3 from 17, I'm going to be left with the part of 14. I would love you to say your sentence out loud of the different parts and wholes that you had. We should all have the whole of 17, but which parts did you have? Say it out loud now. Oh, there are lots of different ones. I can hear them. Yes, there are lots of different ways we can make that same whole of 17. So, you've got a chance now. You've got one extra that we haven't done. I've just given you one there of 14 and 3. You might have something different. So I want you to spend a little bit of time finding different ways we can manipulate that whole of 17 to give us some addition number sentences and subtraction sentences, realising the two different parts that make that whole. Pause the screen and get your adult to check how many you have done and whether they are correct or not. Good work. We're really happy with your work in that activity. Pause the screen, get that done. So, year one, there are lots of different ways to do that, and hopefully your adult has helped put you on the right track and realise how many different ways they are. We've got a different whole now. We've got a whole of 20. And just like 17, there are many different ways we can make this whole of 20 with two different parts. So have a go now, using the number 20, completing the part of our whole models of finding many different ways we can make 20. You can then go off and write some addition number sentences. And if you want to, you can write some subtraction sentences as well, because I know you've been working super hard on that. Off you go. Pause the screen to give yourself more working out time. Right, what we'll have noticed is if we've got a small part of 1, we need a large part of 19 to get to 20. If we have a slightly bigger part of 2, we need a slightly smaller part of 18 to get us to 20. If we've got a slightly bigger part of 3, we need a slightly smaller part of 17 to get us to 20. If our part of 3 increases to 4, our part of 17 will decrease to 16 to get us to 20. And then if we've got a part of 5, 1 less than 16 is 15. So one side we give him 1 more to, but the other side loses it. So the part is moving around, isn't it? So we can see that that will also equal 20. Then we're going to have 6 and a part of 14 to get us to 20, and so on as we go from 7 and a part of 13 to 20, 8 and a part of 12 to get us to 20. So we can see this number's getting bigger, but this number's getting smaller. So one part is getting bigger, the other part is getting smaller to get us to that part of 20, that whole of 20. Then we've got 9 and 11 will get us to 20, and 10 and 10 would get us to 20. And then we can put the parts in the different order. So well done if you managed to recognise that fantastic pattern. Number has lots of different patterns we can work with. So well done. This time we're going to continue working on recognising more than, fewer than or equal to. But this time today we're going to try and use the symbol ourselves. Okay? So we can see that this number is either more than, fewer than or equal to this number. First we need to find out the numbers. We've got 10, 20. 20 is, oh, that's definitely more than. We can see how big that part is. 20 is more than 9, 10, 11. 20 is more than 11. And this is what we call the more than sign, because we can fit more in that part. 20 is more than 11. Fantastic. So we've got 20 is more than, it wasn't fewer than, and it certainly wasn't equal to 11, sorry, it was more than 11. I would like you to choose the sign to write in each of these boxes to make that sentence true. So 20, is it more than, fewer than, or equal to 16? You can use the sentence below to help you as well. Then can you do the same for 17? Is more than, fewer than, or equal to 12? Have a look at which symbol you need to use. Pause the screen to give yourself working out time. Right, what did we find out? 20 is definitely more than 16. So we've got our more than sign. It's got more in that part. And 17 is also more than 12. 17 is more than 12. So we can fit more in that part of the symbol. So really think about this picture in your mind as you are choosing the correct symbol to use. 20 is more than 16. 17 is more than 12. Right, can you help me out with this one? So what number do I have? I've got 10 and 5. Oh, great, that's 15. Is, oh, there's not as many, is there? So it must be fewer than. 15 is fewer than this number, which is 10, 11, 12, 13, 14, 15, 16, 17. Yeah, if I had 15 sweets and you had 17, I'd be so jealous. Because I've got the fewer amount. So 15 is fewer than 17. Can we see? There's fewer that can fit in this part of the symbol. So 15 is fewer than 17. Now, I would like you to have a go at choosing the correct symbol to finish this number sentence. So is 18 more than, fewer than, or equal to 20? Is 21 more than, fewer than, or equal to 4? And you might use that sentence at the bottom to help you. Pause the screen to give yourself working out time. Off you go. Great, what did we find out? 18 is fewer than 20. So we've got the smaller part of the symbol with our 18, which is a smaller part of that number sentence, the larger part of our symbol with the larger part of our number sentence. And we've also got 21 is more than 4. It's way more than 4. And as you can see, we're going to be able to fit more in that part of our symbol. 21 is more than 4. So you're going to help me with the picture side, then you've got some number sentences to do on your own. So we've got, I'm going to start with 9, 10, 11, 12, 13, 14, 15, 16, 17. We've got 17 and we've got 6, 7, 8. So is 17 more than, fewer than, or equal to 8? Yes, it is more than, isn't it? 17 is more than 8. 17 is more than 8. Let's look at our more than symbol. We can see it, can't we? 17 is more than 8. 17 is more than 8. Right, are you ready? You've got some number sentences to complete. In the box, write the symbol that makes this true. Off you go. Pause the screen to give yourself more time. Right, so 13 is certainly more than 3. We can fit more in that part of our symbol. However, 13 is actually less than 31. 31 is such a big number, isn't it? 31 children in the class, that would be a huge class. 13 is fewer than 31. 13 is fewer than 31. Couldn't get my words out there. Got to be careful. Make sure I take my time. Now, this symbol. Have we seen this symbol? We have earlier on in the session. Wonder which one this might be. So what do we have? We've got 6, 7, 8, 9, 10, 11, 12. And we've also got 10, 11, 12. 12 is more than, fewer than, or equal to 12. Yeah, they're equal, aren't they? They are the same, so that's why we have that symbol that is balanced. And we can see that they are the same, equal to. So when you are writing 1 and 1 equals 2, that's why, because they're the same. 1 and 1 is the same as 2. 6 and 6 is the same as 10 and 2. So now, having a look at our number sentences here, can you please add in the sign more than, fewer than, or equal to complete the sentences? Pause the screen to give yourself more working out time. Right, what did we find out? 11, 10 and 1, what's 10 and 1? 10 is also 11, so that means that 11 is equal to 10 and 1. What about 13? Take away 3. 13, take away 3. 12, 11, 10. So that's actually 10. And 10 and 11, 10 is fewer than 11. So they're not equal, are they? It's fewer. 10 is fewer than 11. Great work if you managed to spot that. To finish you off today, we've got 3 number sentences here. I would like you to find out whether we need to use the term more than, fewer than, or equal to by saying it out loud. And then I have got the symbol hidden under here. So see if you can use the correct symbol to show me the different answers. Off you go, pausing that screen to give yourself more time. Great, let's go. 13 and 5 is 18. And we've only got here 10 and 5, which is 15. So we know that 18 is more than 15. And hopefully you have the symbol 18 more than 15 to go with that. Good work if you managed to get that. 12 and 3. 12 and 3 is 15. 14 and 2 is 16. So 15 is fewer than 16. Let's see if we've got the symbol. 15 is fewer than 16. So hopefully you managed to solve that one. Then we've got 17 take away 7, which is 10. 16 take away 6, which is also 10. So we know that 10 is equal to 10. And hopefully we've got that symbol there too. That's fantastic work from you today, Year 1. 3 completed activities in your maths. Keep practicing and keeping those skills nice and sharp. Thank you for joining.